Before we start talking about polarity and molecules, which is what the emphasis of this video is, I want to remind ourselves of polarity and bonds, just because I want to be able to distinguish the difference. They are connected to each other, but how we approach them is a little bit different. So in a previous video, I presented the idea of a bonding continuum that went from nonpolar covalent molecules all the way to ionic molecules. And in between nonpolar and ionic were polar covalent bonds. And how we determined if a bond between two atoms was polar, nonpolar, or ionic was by looking at the difference in the electronegativity values of the two atoms. And remember, electronegativity values are numbers that tell us the attractive power or the attraction that an atom has for electrons in a bond. And the higher the value, the greater the attraction that atom has. So when we were looking at it, if two atoms had very similar electronegativity values, they shared equally, and that was called a nonpolar bond. If two atoms had a little bit farther apart electronegativity values, then we would say they shared unequally, and that was a polar bond. And polar bonds, because they share unequally, created dipoles. And a dipole is simply when the charge has a separation in it. And if you recall, or you can go back and watch the video, the atom with the higher electronegativity would become partially negative, and the one with a lower electronegativity would be partially positive. And then lastly, if the electronegativity value difference is so great, then the electron is actually transferred, and that creates an ions, which causes ionic bonding. Okay, so that's just a little quick review, verbally anyway, of polar and nonpolar and ionic bonds. So before we talk about molecules, I want you to know that the idea of polar and nonpolar is the same. So in molecules, you have multiple bonds that are coming into a central atom. And so we have the orientation of all of those bonds. And so when we refer to a molecule as nonpolar, what we're saying is that the electron cloud around the whole thing is equal or even. So when things are nonpolar and things are shared equally, the electron cloud is equal or even around either the bond or, in this case, the molecule. The word polar in bonds means that you have a separation of the charge. Remember, it means that one side has a little more electron cloud and becomes negative, and the other one is positive. So you have this, it's unequal around the bond, and in a polar molecule, the electron cloud is also unequal around the whole molecule. So the molecule can have an overall dipole because the charges, the cloud around the molecule has more concentration in parts of the molecule than others. So I'll try to put it really simply. Polar in both cases mean the electron cloud is going to be uneven or unequal. Nonpolar in both bonds and molecules means the electron cloud is equal or even. Okay, so the word polar and nonpolar are referring to very similar situations for bonds and molecules. Okay, so we're not changing the meaning of the word polar and nonpolar. So let's take a dive in now And look, and I know that's a lot of talking with nothing happening on the screen, but I just kind of wanted to get us verbally on the same page. So now let's look at the screen, and this first one just says, classifying a molecule as polar or nonpolar will depend on two things. It depends on the individual molecule and on the shape. Okay, so the shape comes from the Lewis structure. So as we start to talk about the polarity of molecules, we are going to base it on the Lewis structure. As you proceed in chemistry, you gain more experience, and then you'll kind of look at what the molecule's doing and kind of have a better idea. You won't always have to write the Lewis structure, but we're going to start with the Lewis structure because that has to do with the overall shape. Now, two things, and you don't have to memorize these things. These are just generalities, but nonpolar molecules tend not to have polar bonds, or they'll have individual bonds, dipoles, which means individual polar bonds that will cancel each other out. Okay, so they can either not have any polar bonds, so all their bonds are sharing equally, or they have polar bonds, but how they're oriented, they cancel each other out. It's actually vector math, which I have questions. We're not doing vector math, don't panic, but that's what they mean canceling. Polar molecules in general will at least have one polar bond, or I suppose, they can have bond dipoles that do not, and this should be cancel, that do not cancel. All right, so you don't have to memorize those things. Those are just some general things about polar and nonpolar molecules. So I have some little questions you would ask yourself from a Lewis structure, and this is like on the exam, this is where you'll start. You'll start with a Lewis structure and to decide if a molecule is polar or not. And I want to show you an example of a Lewis structure that you would answer yes for each question. Now, you want to ask the questions of yourself 1, 2, 3. So you're going to ask them in that order. The first question just says, are there lone pairs on the central atom? All right, so we had a Lewis structure like this that we've used before. And so this is an example of answering yes to the question. So it says, are there lone pairs on the central atom? So just like shape, we're going to pay attention to the central atom. And you have lone pairs right there. So this would be a yes. So this is a polar molecule. So polar just means that the electron cloud is unequal. And if you have lone pairs on the central atom, I always think of it like an ice cream scoop of electrons. So right then it is unequal because you just took a big scoop of electrons and they're on the central atom. So this would be a question of yes. That's an example of the answering yes to the first one. Number 2, let me draw an example of this. So this is a molecule that we did. I need to move it over just a little bit, okay. And I'm not drawing the shape, although we could draw the shape. It won't matter. All right, and so on this one, let's look at the central atom, which is carbon. And so you would ask question 1 first. So are there lone pairs? And we'd say no lone pairs. And so in the questions, you would say to the first one, no. And so then you would go to the next question. And so the next question is, are the atoms attached, or this is bonded, to the central atom, different elements? And I always have to clarify this, not different from the center atom, but different from each other. Okay, so then what we do is we look at the elements. So we have a hydrogen, and an oxygen. So that oxygen is different from the hydrogens. So the answer to our question is yes, the atoms are different from each other. So this molecule is a polar molecule. So let me go over that one more time since it was a little different. So we asked the first question, are there lone pairs on the central atom? So it doesn't matter that they're on oxygen. We look at carbon and there are no lone pairs on the central atom. So since there were no lone pairs, we ask the next question. And the next question is, are the atoms attached or bonded to the central atom different elements? And it should be different from each other. We're not worried about the identity of the central atom. We want to know, are the elements bonded to the central atom different from each other? And so we have two hydrogens, but one oxygen, and it only takes one element being different to make it a polar molecule. Because what happens is, in the overall picture, oxygen is much more electronegative than the hydrogens, so around the carbon, the electron cloud will want to be drawn toward the oxygen. And remember, polar just means that the electron cloud in the molecule is uneven or unequal. Okay, so that would be an example that fits a yes to question 2. So now let's look at a yes to question 3. So this is another molecule that we did. Okay, so we wouldn't start with question 3, even though I've told you that that's where we're headed. We would go down, and so you would look at the central atom, and you ask question 1, are there lone pairs on the central atom? And the answer is no. There are lone pairs in the molecule, but none on carbon. Remember, on the central atom, you would have dots on the carbon. That's what it means to have lone pairs on the central atom. Trying to get rid of them. Okay, so no, go to the next question. So question 2, are the atoms bonded to the central atom different elements? Okay, so we have chlorine, 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 chlorine. So they are not different from each other. And so if you look at question 3, are the atoms attached to the central atom the same element? And not as the central atom, but as each. I really need to change this. As each other. So we're not worried about the identity of the central atom. We're looking at the atoms around the central atom and asking ourselves, are they the same element? Are all of them the same? And so these are all chlorine. So yes, then this